Hello guys, welcome to my channel. This is Rathin Datta. Today we will be discussing about the shoe brakes that we see in our bicycles and also in our trains. Okay, they used to stop the wheels using two shoes or a single shoe arrangement. Okay, so initially in the last video we have studied there are three types of shoe brakes: single shoe brake, double shoe brake and pivoted shoe brake. In this video we will be studying the three cases of single shoe brake. Okay, along with it there will be two sub cases in each of the cases. Okay, the first case is the braking torque force passing through the fulcrum. Second case, the braking torque force is passing above the fulcrum, and the third case is the braking torque force passing below the fulcrum of the brake. Okay, in each of the three cases there will be a clockwise motion of the drum and anti-clockwise motion of the drum. So let's see how we do it. So guys, this is the thing I was talking about, that is the single shoe brake. Okay, in this case we will be, as we have discussed, that we will see the three cases, right? First one, the braking force or the torque force passing through the fulcrum, then the braking force passing above the fulcrum, okay, then the braking force passing below the fulcrum, okay, this one. So in the first case that we have drawn in here in the downside of the screen, as you can see, we have shown it by the black mark, this one, right? So you can see it is actually this force, this entire thing is in the same line, that is the fulcrum. At the fulcrum is the point at which the system can rotate, right? So we are applying external force in here. Okay, this is the brake drum, as you can see, this thing. This entire thing is a brake drum. Okay, next the point at which it will move or the movement will take place is the fulcrum, right? And this is the green part is the shoe brake or the shoe. In here you can see we have taken this angle as theta. This is called angle of contact. So your angle of contact actually should be, that is 2 theta, should be actually less than 60 degree. To have a uniform contact between the drum and the shoe. Okay, this is for a good brake. Your 2 theta should always be less than 60 degree. Okay, are you getting my point? So the point at which the external force P is applied is at a distance L from the fulcrum, and this is the X distance from the reaction force. Okay, this is the X. Okay, as you can see there are two forces generating as the drum is revolving clockwise direction. Okay, clockwise direction. This is the FT force, this is tangential braking force, or you can say that the tangential brake force or brake torque force, whatever, FT, and this is the friction force. So if the FT is in this way, it will be in this way, as you can see, this force, right? So your FR is actually nothing but mu into Rn. Are you getting my point? Okay, where mu is the coefficient of friction and Rn is the normal reaction. So if we take moment about O, that is the fulcrum O, what will happen? It will be nothing but, it will be, that is summation of M about O will be what? If we can make it up to 0, then we can have an equilibrium system. So it will be nothing but, in simple, it will be Rn into X equal to P into L. This Rn into X will try to rotate the system or the fulcrum into clockwise direction, but this P into L, this moment will try to rotate the system into anti-clockwise. So Rn will be equal to X. So your Rn will be what? Rn will be PL by X, P into L by X. Okay. Okay. So our braking torque force will be what? It will be TB equal to FR into or you can say FT, because FT is actually equal to FR. Just the directions are opposite, right? FT into the radius R. Okay, radius is the R is the radius of the brake drum. Okay, so FT is what? Equal to FR. Okay, so what we can do is that we can put the value of Rn, that is first we will put Ft equal to this thing, Ft equal to Fr, that is equal to mu Rn. So it will be what? Mu into Rn, okay, into R. In place of Rn, we can put this value, that is mu PL by X into R. So your TB becomes this, mu into PL by X into R. This is your braking force, or you can say braking torque force. Okay, this is the first case of the single shoe brake where the braking force or the tangential force is passing through the passing through the fulcrum. Okay, so in our next case, but you can see this is the clockwise case. As you see, this is the clockwise case. In the first case of the braking force or the tangential force passing through fulcrum, whether it is a clockwise or anti-clockwise, this expression, this below expression TB equal to, TB is what? Your braking torque. Ft is what? Your tangential braking force. So force into distance is giving you the torque. It is the braking force, that is Ft, and TB is the braking torque. Okay, so whether it is clockwise or anti-clockwise, this expression will always be same for the first case. For the first case, it will always be the same. So coming to our last two cases, as you can see, this is the braking force passing above the fulcrum, and the third case, as you can see, passing below the fulcrum. So passing above the fulcrum, taking moment about O, what it will give us? Okay, as you can see, it will be simple, P into L. Yes, P into L. In this side, it will be what? Rn into X plus, yes, Rn into X, Rn into X minus Ft into A. This distance is taken as A. Okay. So if you can see, this PL with P into L is trying to move the fulcrum in clockwise direction. Okay. But this Rn is trying to move the fulcrum into anti-clockwise direction. Again, this Ft is trying to move the point into clockwise direction. So it will be actually PL plus Ft into A is equal to Rn into X. These two moments are the clockwise moment, and this one is the anti-clockwise moment. So Rn will be what? Rn will be nothing but PL into X. Sorry, Rn will be P into L X minus mu into A. Okay. So you can easily find out, that is your, if you know the braking force or the tangential braking force, you can actually find out the tangential brake force or the tangential brake torque or the brake torque, simple brake torque, right? It will be what? Ft into R. Okay, Ft is nothing but your Fr into R. So Fr is what? Mu into Rn into R. So it will be somewhat like that. If you totally place it, it will be mu PL into R divided by X minus mu into A. Your TB will become like that. Okay, for the braking force passing through, the tangential braking force passing above the fulcrum. But in this case, please remember, this is a clockwise case. If we change this clockwise to anti-clockwise direction, what will happen? Yes, what will happen? The thing will little bit actually change. Okay, the thing will little bit change. What will happen is that your PL, your Ft into A will be, as you have written in this case. Yes, you can see this is minus because your Ft is trying to move the thing into clockwise direction. But if it is anti-clockwise motion, means the anti-clockwise, if there is an anti-clockwise motion of the braking drum, this Ft into A will be in this equation it will be plus. So PL P into L, it will be minus Ft into A is equal to Rn into X. So it will be slightly different if you change the direction of the thing, direction of the breaking term. For clockwise, it will be like that we have solved, but only for anti-clockwise or direction of the breaking term, in this part it will be not minus, it will be just positive, and there will be slightly change in the expression of TB. Okay, as in this case you can see the your fulcrum, the braking force is passing below the fulcrum. This is your fulcrum O. So taking moment about O, it will give us again like that. If you just sort out the equations, okay, it will be simple. P into L, okay, then Rn into X minus Ft into A is equal to 0. Okay, so your Rn will be what? Rn will be PL by, okay, X plus mu into A. Okay, so your TB will become, okay, mu into P into L into R divided by X plus mu into A. Okay, in this case it is also the clockwise direction. Please remember the direction of the braking term is clockwise. Okay, but what will happen is that if it is anti-clockwise direction, okay, if it is suppose anti-clockwise direction, what will happen if it is anti-clockwise direction? The only change will be your this Ft into A will become positive. As in this case it become positive, as you can see, if the drum rotates in the anti-clockwise. In this case also your whole expression will remain, just this Ft into A will change from negative to positive if the drum rotates in the anti-clockwise direction, and there will be slightly change in your value. But for clockwise this will remain the same, that is mu into P into L into R divided by X plus mu A. It will slightly change into X minus mu A. Okay, are you getting my point? So these are the three cases, that is passing through fulcrum, passing above the fulcrum, and passing below the fulcrum. I hope you get the concept what I am trying to discuss here, and thanks once again for liking, sharing and subscribing. Keep subscribing, keep liking, because that motivates me. Thank you so much. Bye bye.